Right. So the question for here we have to define the term pressure and state the unit of pressure. So they say to define the term pressure and state its unit. So pressure is the force acting over a unit area. It's SI unit or units are Newton per meter squared or Pascal, PA for Pascal. Now the formula for pressure is equal to force divided by area. So if you replace force with Newton and you replace area with meter squared, you get Newton all over meter squared. Bring the meter squared on top, you will get Newton per meter squared. That's how I got Newton per meter squared there. And well, another unit for pressure is Pascal. So part two, they say to calculate the liquid pressure that a diver experiences at a depth of 0.5 kilometers below the surface of the sea. So let's say this is the surface of the sea. So this is the sea surface. Given that the acceleration due to gravity is 10 Newton per kilogram and the density of the seawater is this, what are we to get the pressure? So let's say the diver is down here, right? Let's say he has a depth of 0.5 kilometer below the surface. So the depth would be like 0.5 kilometers, right? And we know that pressure in liquids is density by gravity by height or by depth. So we convert this depth to meters by multiplying by 1,000. You will get 500 meters. That is really the depth. Now you could say this is the depth, or you could say that that is the depth that we have there. Um, I will put it as this, right? Um, 0.5 kilometers. So to calculate the pressure, we say the density, which is 1025, multiplied by gravity, which is 10, multiplied by the depth, which is 500 meters. So when we work out this, we're going to get the total pressure, which is 5,125,000 Newton per meter squared or Pascal, right? I will put Pascal. Now the next part, this is a short question, part B here, they say state Archimedes' principle. So Archimedes' principle states that when a body is completely or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced, right? So part two, let's say a boat which has a weight of 3,000 Newton floats in seawater. If the density of the seawater is 1,025 kilogram per meter cube, calculate the volume of the seawater displaced by the boat. So we need to calculate the volume, right? So we would say that the weight of the boat would be equal to the weight of water displaced. So the weight of the boat, are putting WB for weight of the boat, that would be equal to mass by gravity by height, right? That is the weight of the water displaced. Um, Actually, no. Weight is equal to mass by gravity, right? Mass by gravity. That's weight. But what is mass? Well, we know that density relates to mass and volume. Density is mass over volume. So we can write density as density over 1 and cross multiply, making mass the subject. So you have mass is equal to density times volume. So now you're going to replace mass here with density by volume. So you're going to get the weight of the boat to be equal to the density by volume by gravity. Um, so we can make V the subject of the formula. That will be equal to the weight of the boat divided by density by gravity. Let's say the boat, which has a weight of 83,000. So the weight is 83,000. The density of the water is 1,025 times gravity, which is 10. So this gives it the volume, which is 8.1 meters cubed. So this is the volume of the seawater displaced. This is really the volume of the water, the density of the water, because it's equal to the weight of the water displaced. Right? This is the weight of the boat, mass by gravity, but the mass, because weight of the boat is equal to weight of the water. The weight of the water is also mass by gravity. So the mass of the water divided by the volume of the water is equal to the density of the water. Cross multiply, you will get mass of the water is equal to the density of the water by volume of the water. So volume of the water would be equal to the weight of the body divided by density of the water times gravity, which we're getting 8.1 meters cubed. You all understand the solution here, right?